Thanks for that, and thanks for coming. By the way, I'm from New Zealand, so if you can't understand my thick accent, that's why. I apologise in advance, but I try to speak slowly and not mumble too much. So I'm here today to talk about building dApps on Polkadot's Evm solution. I think I've only got slides up here. There we are. We're going to cover a few topics today on our agenda, and focus mainly on how you can build complex, enterprise-level, scalable EVM-based applications within the Polkadot ecosystem. We're going to cover topics like what is EVM, what are the current solutions, what are the tools available to make your life easier, and then how can you use SubQuery to help accelerate this development cycle. Awesome, so let's get started. What the hell is EVM? This EVM thing is Ethereum virtual machine, one of the most prevalent contract execution environments out there. It is widely used in Ethereum, and it's a lot of developers call it like the JavaScript of contract execution frameworks. It kind of sucks, but it's used by everyone. It's universal. So regardless of its issues, it is commonly used by almost everyone in the industry. It's deterministic, it's isolated, terminable. So deterministic obviously means that two people running it around the world gets the same output. It's isolated, it can run within a chain on each block, and it's terminable in terms of the gas fees. If an execution starts consuming too much resources, it can get terminated. But it's very inefficient. It's static, it hasn't changed much, it hasn't been improved that much over time. And it's written in Solidity, which sucks. So you might have heard of this other thing called WASM out there. WASM is another alternative to EVM, and it's been built a bit more on Polkadot. But today we're just going to focus about EVM. So, building with EVM. This is the application stack that we use in EVM. We start with, obviously, the relay chains and the parachains. You can just work with your own Substrate-based chain if you want. From above that, we have our virtual machine. As I said, you can use EVM or WASM. We're going to go through different versions of this later. You have an RPC interface provider, a tool like Dwellia, On Finality, PinkNode, and of course you have your presentation layer, your UI. And all the logic happens, all the business logic happens in the virtual machine. Your data is stored in the parachain, but of course you can actually save data off-chain because storing data on a parachain is a terrible idea. You can use tools like Crust, but also like IPFS to do this. And you might as well throw some oracles in there to bring some data back into the smart contracts, back into your application. So these are your common tools that you'll want to use when you're building an application or a dApp, a decentralized application on EVM. So the outcome of what I want to kind of cover today is that you don't need to launch a parachain, you don't need to run a parathread, you don't need to build your own chain to do stuff. You can actually kind of use what's already been built. And I know it's a flavor of the month or the year, it's fashionable to run your own parachain. I get asked that all the time in AMA. It's like, when are you guys going to launch your own parachain? It's like, we don't really need to right now. You can leverage EVM and WASM to get to market faster. So there's two main supports for EVM in Polkadot. There's Parity's Frontier EVM, and there's Akala's EVM Plus. These are the only two that we're kind of aware of right now, and we're coming. But what we find is actually, even though there's two here, there are literally many teams using this, okay? Parity Frontier is used by most teams, namely like Moonbeam and Astar, and all the other logos down here, and then you have Akala doing their own stuff for whatever reason. You can ask Dan why EVM Plus is going to be the next big thing. But this is a breadth of different opportunities that you can build on. These chains here all support this off the shelf, and they all actually operate in a very similar way. So this is our application stack, but one of the problems about this is that, querying this stuff, right? So one of the biggest problems about blockchain data is that blockchain data is like a book. It's a linked list. It is a chain of blocks. And asking a blockchain for something that's complex, like a query asking, give me the last 10 transactions that I've ever made, or give me what assets I have across all these different parachains. It's really hard to ask that question because blockchains aren't optimized, the RPC endpoints aren't optimized to give you the answer effectively and efficiently. So what we need to use, and what a tool like SubQuery is around solving this problem. So in order to build these increasingly complex and intuitive applications, which what we need to do, right? If we need to bring the next billion people into blockchain, We need better applications that anyone can use. My mum and dad can use, and they're like technophobes, you know? So if we can build applications that anyone can use, we're going to bring the next billion people in. And to be able to do that, we need tools that developers can use to process and query that data faster, more efficiently, more effectively. We've found out that querying data directly from the blockchain works some things, but does not work for many. So a solution like SubQuery is about indexing data. And what indexing is like is basically, rather than asking each block for some information in real time, which is really slow, an indexer scans through the entire blockchain, takes that data off the blockchain, manipulates it, and saves it in a pre-cached format exactly in the format that you need, in an efficient storage that you can query. It's an open source project. We index, transform, and query data using GraphQL. And it's like a custom API for your app. It's a custom API that you can then build off, and you can build whatever you want to build from it. And people ask me all the time, you know, what kind of customers do you have? Well, it's literally anyone that wants to build a performant, user-friendly interface. It's any application. It's not just applications, but it's also people want to understand their chain more. Who's using it? What's happening? What are the events and extrinsics that are going through? Analyzing data on the chain is what we do. It's bread and butter. So in our application stack, data indexing fits in here. It's an alternative way to take data from the chain and provide it to your application. In a more performant way. So it doesn't replace the RPC interface. Obviously, you still need to submit transactions and stuff on chain, and we don't do that through an indexing solution. But reading data off and putting into a format that you can then query efficiently is what we do. So SubQuery is a leading multi-chain data indexer. And what I want to go through is the 4 main design principles that we take on when we build it. These are like our 4 commandments. First, it's fast. It has to be fast. Everyone's always asking us to speed it up. And we focus entirely on building this index to be as fast as possible. Faster than other solutions out there with advanced indexing caches and pre-computed indices of where things are. So if you ask it to index transactions, it already knows exactly where the transactions are. You don't have to go into each block and peek sequentially for any transactions. It's flexible. There is no off-the-shelf API. You use SubQuery. It's a tool that you wield to take data from the chain, from whatever chain you want, any Substrate chain is supported, and put it into a format that you need. It's very flexible, and it's flexible for the exact application that you're trying to build. You don't have to shoehorn existing data sets to make your application work. You can customize the API. It's your own bespoke API. It's open source, and we're built in a way that's actually quite interesting. We have a lot of customers that have taken we kind of have 3 components. We have an indexer, we have a database, and we have a query service. And we have customers that have just like thrown away half of that and have just used the indexer to put that data into a database that they have in their centralized service. We've had many customers kind of augment this and extend it, and it's always fascinating to see how people are using this tool. Finally, it's universal. We actually work on other chains outside of Polkadot. So we work on every single Substrate chain, but we also work on Avalanche. We just entered Cosmos. We added support for Terra. Unfortunately, things didn't go well there, but a lot of Terra developers were really stoked about it. But really kind of what we're focused on at SubQuery is we believe in that multi-chain future. And I'm sure all of the developers here are thinking about, in the back of their mind, Polkadot's an amazing ecosystem with all these parachains, but you do also have to think outside of Polkadot. Building bridges and other ways that people can interact and move around this blockchain industry as a whole. So we work across all these other chains, and we're focused on Avalanche and Cosmos and Polkadot because all these 3 represent kind of that multi-chain view. Polkadot with parachains, Avalanche with subnets, and Cosmos with their own Cosmos SDK. So it works with all these solutions. Every chain it works with, and any of these EVM implementations that works with off the shelf, which is really cool. And rather than talk about it, let's kind of go on to a bit of a demo. I covered this slide. But let's go on to a demo. Firstly, an introduction of how it works and what you'll see. There are 3 main steps we're going to do today. It's very simple. No pre-made stuff required. We have a GraphQL schema, which is the shape of your data. It's like the final result of what you want. We have a project manifest, which is a configuration, and we have a mapping file, which is the data transformation pipeline. So let's roll into this right now and do this live. I'm going to initialize a brand new project using our command line tool. Let's call it Decoded demo. I can now pick, let me change the size of this. I can now pick what network family I want, Avalanche, Substrate, Terra. There's be Cosmos added to this soon. And this I'm going to use one from Moonriver, an example project, to get me started faster. I'm going to use the default on-finality API RPC endpoint. I'm not going to change with this other settings, just accept all the defaults. And that pulls down a brand new starter project. I'll just seed into it. And I will just open up VS Code. Which open up VS Code. So this is our brand new project. Just been initialized. It was cloned from an example repo out there, so it kind of gets you started. While in the background, it's going to run yarn to install stuff while that runs. Hopefully the internet isn't too slow here. Now, as I said, there's three main files. So the first file is this mapping file. Is the GraphQL schema, the shape of the end result of what we're looking for. This is a GraphQL schema. It is, if you've ever used GraphQL, it's relatable. What each of these entities, and there's two in this default project, a transaction and approval, you can visualize them as like a database table. So a transaction table, and each record has an ID, a value, a to or from, and a contract address. I'm going to add a new one here, which is a collator, and that's an entity, and we're going to index all the collators on Moonbeam today. So we always have to have an ID, which has to be unique. And we're going to have a join date, because we're going to index when they joined and left the collator set. Putting an exclamation mark after my type makes it mandatory. And so exit date is obviously not going to be mandatory, because some people never leave. So my types are still important, and my yarn builder is still kind of going, but I have added a new entity type. And after this runs, what I'll do is do some type generation. It's just taking its merry time, unfortunately, but that's life. Now I'm going to go to the second file, which is the manifest. And the manifest is the what and when are we indexing. In this case, the manifest is doing is indexing data from Moonriver. So this focuses on where. It's going from Moonriver's network. We import some type overrides that Moonbeam bring in, and you can import those type overrides the same way you do in Polkadot.js. And this is how we support every single Substrate chain off the shelf. You don't need to do anything else. You don't have to build a preprocessor. This will work atomically with any Substrate chain. And I have a data source, and data sources is the when we're indexing. So firstly, this contract address is actually it's a Solar Beams token. So we're indexing things around Solar Beam. Solar Beam is a DEX on Moonbeam, and they've got, I think, one of the bigger ones on Moonbeam. And we're indexing in this default project 2 events. These are Evm Events, and this is a kind of a way that you define an event in Ethereum. It's like a topic, and topic always has there's always like 4 options for topics. In this case, we're doing transfer events, and you have calls as well. Calls in this case are like function calls, and we're also indexing approvals. So in this SubQuery project off the shelf, we'll index every transfer that happens on Moonriver, and we'll also index every time that the Solar Beam contract and account approves it for use. I'm going to add another thing here, because we're going to do some collator stuff. I'm just going to copy this from a file, because I don't want to type it out, because typing live is excruciatingly painful. But this is another mapping file. This is indexing, this will be indexing Substrate events. So in this one project, what I actually have is I'll have Evm events, and I also have the Substrate events. So Moonbeam kind of runs both in the same blocks, the same place, but we can join that data together into one data set. In this case, I have an event for collator joined. It's pulled off this parachain staking module, and the method is join collator candidates. And you might ask, how the hell do you know this? Well, if you kind of look in Subscan here, I'm looking at Moonbeam Subscan. They have a module parachains, and they have an event join collator, and you can kind of see the data on this they have an account ID and the balance of when they join that set. So this is kind of how you can see and see what data that's stored in the payload. I'm just a bit worried that my yarn install is still not done. Anyway, the final file I'm going to edit is our mapping file. Now, the mapping file takes the data from the chain and it puts it into that format that we defined at the start. So from this example project, there's already some stuff here. There's a handle frontier Evm event which receives an event from the chain. It takes off all the transaction data from that, so who sent that, what was the value of the transaction, the contract address, and saves that. And same with frontier Evm call. It takes off the approval event or call from the EVM, it takes the data off it, and it saves it into the database. And I'm going to add one more, or two more actually. I'll just copy and paste this as well. This is two methods for collator join. So this first one will be a collator joined. I'm just going to do this in the background. Collator joined takes that collator type that I defined before. So remember I defined collators here with a join date and exit date, and I also have type gen that out, so it's kind of concrete. And you see these helper functions that saves the database, it removes it, it gets it. And here I can import this and use that within my SubQuery project. I can also add another one which is collator left. This is showing a mutability. So I have collator records, one for every collator out there. There always will be one for every collator that has joined. And whenever you get an event on chain which is saying that the collator has left the set, it will retrieve that collator from the database. It will update the exit date, and it will save that update. And I can build that. And that's how easy it is. That's how easy it is to get a project running that would index every single transfer event for a smart contract, every single approval call, but also every time a collator joins and leaves a set, all in one database, all in one data store. So Docker always messes up my laptop, but let's give it a try. M1 Max and Docker do not mix well. But I'll leave it running in the background. This is going off and it's setting up a database. So this is how easy it's all in one kind of command. It will set up an indexer, which will connect to that RPC node that we talked about earlier. It will then pull data through, put it into a pipeline, process that data according to these mapping functions that I have defined here. It will then take the data from those mapping functions, puts it into a database, or processes it exactly as it's done here, sets up a Postgres database for that, creates the table structures, and then sets up a GraphQL endpoint to then query that data. And you can kind of see this when it starts up. It's very close. I can run localhost, and it still hasn't started up, but it will come through at some point when this gets going. So that's how easy it is to really build a SubQuery project in 10 minutes, right? And I get my data index, and it'll go from this first block to the most recent block, and as soon as blocks are added to the chain, they'll be immediately processed as soon as they're finalized. And that's how easy it is to get data. But you might say to me, James, that's kind of a shitty example. That's really simple. That's not really scalable. I can't really build an application that just tracks collator join events. But this is the foundation blocks of something that's actually for a lot of really complex applications out there. The wallets you use, the explorers you use, many of the applications that you guys will use on a day-to-day basis under the hood relies on data indexing solutions like SubQuery. So in 10 minutes we saw how easy it was to create a project in such a short time, how you can combine Evm and Substrate data seamlessly, how you can use filters to filter certain things to speed things up, and how you can mutate data, updating a data set, a record, whenever something happens. So if we go back to our stack, right, a reminder here of this, this is where that SubQuery sits in. It's in that data indexing piece here. Now, you can run this yourself, and I'm running this, right, and it's currently indexing blocks. It's doing about 2,000, 3,000 blocks per second. And I have it here in this local host that's running, and this is the data that's been indexed in real time. I GraphQL is amazing. You can do some pretty cool stuff, ordering, filtering. You can really build really neat user interfaces. So if you're building a wallet, for example, you want to index every transfer that a team does or every interaction of an extrinsic. You would record that, and you'd be able to filter, the wallet address of the current user, and you get everything that they've done for whole history. If you wanted to analyze crowd loans, you can save every time a bid is made to a crowd loan or to a slot auction, and you can sum up all those bids. Or if you want to figure out what the total crowd loan value is, you can sum up all the bids to get the total, and you can do all the indexing. And one of our biggest use cases back in December was just all that crowd loan data. A lot of that crowd loan data was coming from our project. So you can run this yourself in Docker, like I'm doing right now, but running infrastructure sucks. Many of you guys know this, it really sucks. And so we run a hosted service or a managed service. We're running it for over a year, for a long time now. It's doing like 400 million API requests per day. There's a lot of applications using it. There's hundreds of projects on there. And the best thing is actually you can go on there and actually see it. You can kind of scroll down and look at all these projects out there. We kind of cycle through. Nova Wallet's here, same with Fearless Wallet. Akala's team have got some of their projects building on their applications. There's some Asta projects. There's a lot of like Moonbeam NFT stuff going on as well. And you can kind of go through and look at these projects, and you can kind of go onto Nova Wallet here, and you can see exactly what they're indexing. Sorry, my internet is really slow. I might just stop this indexing when that comes up. But you can actually go in and try out queries. I'll just refresh this. You can try out queries inside the application. You can connect to their actual API endpoint, and you can actually you can see their code base. You can extend it. You can see what they've done, which is really neat. It's kind of building into this openness of this ecosystem that a team can index this data. So Nova Wallet here are indexing what they call history elements, and I can go into their GitHub. I can make requests through their endpoint here, and I of course can make requests through the playground and the app. But the problem is that this service, it's not decentralized. It's a centralized service, and one of the big awkward secrets about blockchain is that there's a lot of centralized services that all these things run on, right? Like our decentralized applications all run on centralized services, and it's kind of a little bit weird. It's a bit strange. We should kind of solve this problem. So we've been literally working for 2 years with one goal in mind over those 2 years, and that is building this project first to do its job well, which objectively we like to think it is, and then figuring out how to decentralize that, and we're really close to that. So we're building a SubQuery Network, which we're trying to build to be the future of Web3 infrastructure, specifically the data indexing infrastructure. And the reason why we're doing this is because we believe that decentralization and tokenization of this is the next big leap. Because if we can decentralize a data indexing service, and then you combine that with the light clients that we've heard about this morning, that is like the last two pieces of the puzzle to decentralize. Your decentralized application literally can't be turned off. Someone in one of the chat groups I was fond of, or I was in, made this statement, we need to get to that point where our whole team can just be driven off the cliff on a bus and everything still carries on as normal, right? So we've been working hard to get to this SubQuery network, and essentially how it works is that you have indexes which do all the work to run the computation, to index data, to sell that data, and they exchange that data for SubQuery tokens from consumers. So if you're building an app like a wallet, you would reward certain indexes with SubQuery tokens, and in return they give all your users that data. And the best thing about that, though, is if we have multiple indexes running around the world, SubQuery is like a CDN, a content delivery network. It's read-only data. So the more indexes we run around the world, the better performance that everyone gets. The more decentralized it is, the better performance that our customers of our service receive. So we've been working on that a lot, but one of the key things that we need for this decentralized service is an API, like an admin app that indexes can use to actually onboard, to get in there. We've launched this test net. We've actually launched the third and final phase today. And indexes are probably slowly getting on, actually. I might see if there's any in there right now. There's about 11 indexes that have on board in the last 2 hours. And they index certain projects. And I can go in here and I can see what projects that they're indexing. This one hasn't done anything yet, but I can delegate to them. I can support them with certain subquery tokens. I can explore the different projects out there. I can make requests to them. This one's from Terra, not from Terra, sorry, from Juno, which is a Cosmos project, and indexes all the Terra Developer Fund recipients. I can make offers, so if I want certain data, I can offer an indexer a fixed price for that data and get that in a more reliable way rather than paying on a transaction fee basis. But this UI that we're seeing here live is an actual application. We're designed to be as user-friendly as possible. It's really key for us. Both for indexes to be able to, in this diagram here, to be able to index a project, or to set up the project that they're indexing, or to delegate to indexes, or to view leaderboards of all the challenges that we're doing in our decentralized network. And what's interesting about this is that this application that we're building and running, and is running live out there, it's real. This project itself is using this stack. So we have the presentation layer, and going through this, we'll start at the bottom. We have we use an Evm smart contract on the Carla's parachain. We're using on-finality RPC endpoints. We're building a front end in React. We're using IPFS for storage. And, of course, we're using SubQuery. So the SubQuery application is using SubQuery. When we look at the code, like this is our Solidity smart contracts, the same smart contracts that you'd write if you're deploying on Ethereum or on Moonbeam or on a Carla. It's the same stuff. And we've built with this. This is a smart contract for us to change stake for an indexer. Then you have our actual network project. So this is the front end of our, or this is a subquery project that indexes the data for our front end. And again, it's the same, this is a manifest file that I created earlier that you saw me create. It's just a lot more complicated. So we have all these different events for delegation added, delegation removed, unbound request, unbound withdrawn. All these different events are indexed, and we do stuff and update stuff based on them. What you might notice is that it looks the same, but this is actually a Carla. So the same way that you build Moonbeam, which we did before, you build a Carla. It's the exact same. The only thing that changes really is these kind of kinds. But it's the same topic structure, it's the same mapping functions, and it's not just the same between a Carla and Moonbeam's EVM, it's the same across Substrate, it's the same with Terra, it's the same with Cosmos, it's the same with Avalanche. All these use the same structures and the same files and the same kind of project. You just change a few parameters, a few different events, a different RPC input you're going to, which makes life really easy when you want to be more and more cross-chain. This is the front end. This is our React front end. Again, standard code that everyone in this place knows, right? React is kind of the base level of front-end coding, and it's everything that we need. And it's kind of funny when you talk to people and you say, I work in blockchain, and they're like, you must be like a crazy developer to work in blockchain. And it's like, no, half the developers in blockchain are just like normal developers. There's some Solidity people out there or Rust people that are super scary. But most people are kind of just using React or whatever, building front ends for it. And that's one of the outcomes here, is that this subquery network, the application that we built, which is designed to run thousands of subquery projects in a very decentralized way. We already have hundreds in our managed service. We're shifting them over to the network as soon as it's ready. It's designed to scale. It's designed to support not just Polkadot, but all these other layer ones. That subquery network itself is reliant on the subquery project to index that data that you see in the UI that you can then use to access the network. And so, in a way, that project that we have used to index data for the subquery network application will be actually the first project that will run on the network. So we've got a little bit of a inception happening here. So it's a perfect example here of how you can take that really simple demo I showed you, really basic, and you can just scale that up, and you can build huge, scalable, decentralized applications that can support thousands of transactions, hundreds of millions of users, and you can build them in an open way, and soon in a completely decentralized way. So that's really what I want to talk about today, is how to build decentralized applications in a large scale on the existing EVM solutions. You don't need to build your own parachain, okay? Don't have to do that. You can still go there later, like we might migrate to our own parachain in the long term, but for now we can get to market faster by using EVM or WASM to achieve the same outcome. So yeah, thank you.
Okay, I'm back. Hi. So, if you have questions, we have plenty of time for questions. Just raise your hand and someone will bring a mic to you.
It's always a good sign.
Nothing? I said raise your hand and a mic will come to you. Go, I'm gonna go.
I would have to formulate it a little bit. Okay, I think we should be fine. Yeah. What has been your primary customers of this solution? Where do you see the biggest areas that are being used? Because there's a lot of many DevOps opportunities I can think of, but what has naturally occurred besides the obvious wallets and Akala dashboards?
Yeah, we have a lot of wallets. Like Subscan uses us in parts of their piece. Really, it's just most UIs, most applications out there. Even a lot of NFT platforms, Metaverse. There's some weird stuff going on. Even the teams use it for their own applications, like Akala's staking dashboards, the way you interact with AUSD. A lot of that's running off SubQuery. But going away from even the UIs, the UIs are the main use case, but if you just wanted to analyze a chain, if you just want to know how things are doing, just give me a daily count of the number of transactions that have happened, or give me a daily count of the number of events, because that's a great uptake or a great metric for us as chain developers to know. You can use SubQuery to index that. It's really kind of open in that way, and then we're kind of continually surprised by what we find out in terms of how customers are using our software. We kind of, a lot of people don't use our hosted service, and we kind of just suddenly find out that, this team's using it. Or we, every morning, hop on and see all these new projects that have been deployed and reach out to them and kind of talk to them about what they're doing and learning from them. One of the biggest challenges for us now is there's a lot of duplication of effort in this ecosystem. Everyone's building their own chain, which everyone has to build their own tools on their own chain, and a lot of people are sharing that, but there's still a lot of duplication of effort. So one of the challenges for us is how do we build standard data interfaces that if you wanted to build a new application that could work on every parachain off the shelf, you don't have to kind of interact with everyone, you don't have to connect and learn the idiosyncrasies of every new parachain. Every parachain is slightly different, and it's painful enough that we see SubQuery as a great opportunity to kind of even out a lot of those data contracts. We talk lots teams like Nansen, these big analysis teams, and they're just Polkadot's too hard because everyone's doing things just slightly differently. It's just infuriating. So SubQuery can be there to kind of solve that problem by providing that standard interface.
So then one and then two.
Hey, James.
Hey, Jonathan.
You guys are supporting a lot of different networks, and that's really awesome. But now these networks are starting to communicate with each other via lots of these XCM channels. So it would be useful if you can kind of index an event or a series of events that might start on chain A and finishes on chain B, so that different front ends can kind of present that as one action. What work are you doing in that regard?
Yeah, XCM is certainly the big opportunity for this ecosystem, and it's as Dan Rees has said before, Polkadot has just launched with the start of XCM. From our perspective, it's quite tricky. I spent an hour on the phone with Francisco from Moonbeam just trying to work out how do we correlate one XCM event on Akala with what happened on Moonbeam, because it's not quite sorted out yet. There's a lot of things still to happen. But we are working quite hard on it. So we're working with HydraDX, Akala, and Moonbeam to actually do a $20,000 grant with the Polkadot Hacker House right now, the hackathon that's happening in North America, for a team to build an XCM visualization, because at the moment you just can't see what's happening. There's some tools that people built that show you what channels have been opened, but you don't really see like how messages are flowing around. And that's one kind of UI or one graphic that I think will really help us communicate the value of this ecosystem to people outside of the ecosystem. There are challenges from a technical point of view of this. So one option you could do is you have a subquery project that indexes other subquery projects. The other one is you could have a subquery project that indexes 2 chains at once. The problem is the subquery project has to be deterministic. So you have to deal with like what happens if blocks stop on one side and carry on the other. You kind of can't, it's hard to kind of correlate that in a deterministic way that's sequential. You can check block timestamps, but it's a bit tricky. So we're working on that right now, but it's something that definitely is front of our mind as it is with many of the other teams here, I'm sure.